So let's look at sample problem 5.11 in your textbook where we're going to predict the products of hydrogenation. And on the slide are three different alkenes. So they have double bonds, and the first is a condensed structure and the other two are skeletal structures. And they're asking you to determine what the products will be after complete hydrogenation. So pause the video and see if you can figure out what the products will be. So a hydrogen molecule, if we draw the Lewis structure of a hydrogen molecule, this is what it looks like. So our X and our Y part of this molecule are the same. When we add a hydrogen molecule across a double bond, we're going to go from an alkene to an alkane. So from an unsaturated hydrocarbon to saturated. So as we look at the examples, the first example there are 1, 2, 3, 4, 5 carbon atoms, and when we hydrogenate that double bond, it'll just become a single bond. So the number of carbon atoms stays the same, 1, 2, 3, 4, 5, but each carbon now has the maximum number of hydrogens. And then in B, there were 2 double bonds between the 1 and 2 carbon, 1, 2, 3, 4, 5, and the 4 and 5 carbon. The number of carbon atoms does not change, but what happens is those hydrogen molecules add across the double bond, and now each carbon is tetrahedral and has the maximum number of hydrogen atoms. The last example is a fatty acid. There's the carboxylic acid functional group at the end, and we also notice that the alkene part, or the double bond part, is in the cis formation. So when we add hydrogen across those bonds and it's complete hydrogenation, those double bonds become saturated with hydrogens and become alkanes. So the number of carbon atoms doesn't change. In our alkene, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 carbon atoms, and it's the same in our saturated fatty acid. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.